This video will go through the steps of how to find the moment about an axis of any three-dimensional object. What is the moment about an axis? So the moment about an axis is the tendency of a force to cause rotation about an axis. The equation used to find moment about an axis is the unit vector of the axis dot the lever arm cross the force vector. So the equation that we use is up top. This symbol stands for the unit vector of the axis dot r times f. In this equation, you must use the dot product as well as the cross product to get your answer. In this example, we have a cellar door with the force 0 newtons I plus 4 newtons J plus 2 newtons K being applied to it, causing rotation along the AB axis. The force is applied outwards from the cellar doors at the handle. Based on the diagram, we can find the lever arm, or R, which is equal to the measurement 0.8 meters I. This is found because it is the distance between the handle where the force is applied to the axis of AB, where the rotation is. We can also determine the unit vector of the axis to be 0 newtons I plus 1 newton J plus 1 newton K, because the axis AB has a J component and a K component, but not an I component, because it does not move left or right. Now that we have determined both the R and the F, we can find the cross product using R cross F. When using the cross product, any I, J, or K component crossed by the same component equals 0. So, for example, 0.8 meters I cross 0 newtons I equals 0 and cancels out as seen. While 0.8 meters I cross 4 newtons J equals 3.2 newton meters K, which is found to be positive using the right-hand rule. And the last cross of 0.8 meters I and 2 newtons K is equal to a negative 1.6 newton meters J, which is also determined using the right-hand rule to figure out if a component is negative or positive. So now we have the first part of our equation, R cross F, which is equal to 0 newton meters I minus 1.6 newton meters J plus 3.2 newton meters K. With the cross product part of the equation now complete, we can now dot the unit vector of the axis 0 newtons I plus 1 newton J plus 1 newton K with the R times cross F component that we found previously of 0 newton meters I minus 1.6 newton meters J plus 3.2 newton meters K. When using the dot product, the only calculations that equal anything other than 0 are the calculations between the same components. For example, an I dot an I equals a positive or negative number, while an I dot a J or a J dot a K will always equal 0. You could see this as we go through the dot product. Any I with a J or I with a K is canceled out because it equals 0. After doing the dot product fully out, the vector components cancel out and you get the equation 0 newton meters minus 1.6 newton meters plus 3.2 newton meters, which equals the final answer of 1.6 newton meters. Therefore, the moment about the AB axis caused by the force vector from the handle of the door is 1.6 newton meters.